Critical minerals, essential for everything from clean energy to cutting-edge technology, are increasingly controlled by a single player, China. Our next report takes a closer look at the grip China holds on the world's minerals and manufacturing.
One morning in America, you wake up and discover that your new phone is delayed, your favorite electric car is suddenly unavailable, fighter jets are grounded, and even wind turbines are stuck in the factory. Nothing exploded. No war broke out. No headline screams about a cyber attack. Instead, somewhere on the other side of the world, one country quietly turned down the supply of a handful of strange metals with hard-to-pronounce names, and the world's technology engine began to stall. Those metals are rare earth elements, and right now China controls most of the mining, refining, and magnet making that keeps modern technology running. In this story, we're going to unpack how China built that grip, why it matters so much for America's tech future, and whether the United States can actually break free before that invisible switch is flipped for real. Rare earth elements are a group of 17 elements with names like neodymium, dysprosium, and terbium. They are not truly rare in the ground. The problem is that they are scattered, difficult to separate, and messy to refine. You only need tiny amounts of them, but they are hiding inside almost every advanced device. They sit inside smartphone speakers and vibration motors. They power electric vehicle motors and wind turbine generators. They help guide missiles, drive radars, and control fighter jets. Think of rare earths as the seasoning in high-tech manufacturing. You do not notice them on their own, but without that pinch of special spice, the entire dish fails. So how did China end up holding so much of this hidden power? Back in the 1980s and 1990s, rare earth mining and processing were spread across the United States, Australia, and other countries. The work was dirty, the chemistry was complex, and stricter environmental rules in many places made it expensive. China made a different bet. Beijing accepted more pollution at home and poured state support into rare earth mining, refining, and magnet factories. The goal was simple but bold: dominate the full chain from raw rock to finished magnet. As the years went by, Chinese producers offered steady supplies at lower prices. Mines and processing plants elsewhere closed because they could not compete. Step by step, the world shifted to buying from China. By the mid-2010s and into the 2020s, China was producing the majority of the world's rare earth ore and an even larger share of the refined oxides, metals, and high-performance magnets. Everyone else got comfortable with the idea that China would always be there as the cheap, reliable supplier. It felt safe until it suddenly did not. We have already seen what happens when China decides to squeeze the tap. In 2010, after a maritime dispute with Japan, China temporarily cut rare earth exports to that country. Prices shot up, buyers panicked, and industries around the world got a taste of how fragile the system really was. More than a decade later, the pattern became sharper. In 2023, Beijing introduced export restrictions on gallium and germanium, metals that are crucial for chips and high-end sensors. Then it tightened control over some rare earth technologies, especially the know-how needed to make the most advanced magnets. In 2025, China expanded its export controls and licensing rules again, tying them more directly to national security and to how foreign companies use Chinese materials. Suddenly, it was clear. These were not just trade tools. They were levers of geopolitical power. And one of the countries most exposed is the United States. For years, the United States allowed its own rare earth industry to fade. As devices got smarter and weapons more advanced, the country kept importing the critical ingredients, often without much public attention. By the end of the last decade, most of the rare earth materials that fed American factories came from China. Things were even more lopsided in the later stages of the chain, where concentrates are refined into oxides, metals, and then magnets. That means a big slice of America's tech future runs through Chinese facilities. Electric vehicle motors rely on neodymium and dysprosium. Wind turbines need powerful permanent magnets to generate electricity efficiently. Data centers depend on hard drives and components that use rare earths. Precision guidance in missiles, radar systems, and jet engines often cannot function at the same level without them. Security experts have been blunt. This dependence is a strategic vulnerability. If relations between Washington and Beijing worsen, disrupting rare earth supply would be a tempting pressure point. Even a partial slowdown with tighter licenses and higher prices could jam just-in-time factories in sectors from consumer electronics to defense. Now comes the strange twist. The United States actually has its own major rare earth deposit, the Mountain Pass mine in California. For years, that mine dug up ore and produced rare earth concentrate. But there was a catch. Most of that concentrate was shipped to China to be separated and refined, because that is where the majority of the processing capacity and expertise existed. So America was mining its own rare earths, then sending them to China for the hard work, and buying back the valuable products. The raw material lived under American soil, but the value and the control lived elsewhere. Recently, this has started to change. Facing new export controls and growing geopolitical pressure, the company running Mountain Pass has been building its own refining lines and a magnet factory in Texas. In 2025, it stopped shipping rare earth concentrate to China, signaling a serious push to rebuild a complete domestic supply chain. It is a big step, but it also shows how deeply entangled the two economies have become. To understand why this matters so much, you have to zoom in on magnets. The real prize in this whole story is the neodymium iron boron permanent magnet. These magnets are tiny but incredibly powerful. They allow electric vehicle motors to be compact yet high torque. They shrink the size and weight of wind turbine generators. They enable highly precise movements and control in missiles, satellites, and drones. Almost every stage of this magnet supply chain is heavily concentrated in China, from refined rare earth oxides to metal alloys to finished magnets. Replacing these magnets with other designs is possible in some cases, but often means losing efficiency, adding weight, or raising costs. So the choke point is not just the ore in the ground. It is the high-value processing and magnet making that sit on top of that ore. This turns the situation into a race. Across the United States and its allies, billions of dollars are now being poured into new mines, separation plants, magnet factories, and recycling facilities. Officials talk about securing the rare earth supply chain by 2030, building enough capacity to cover most domestic demand from the United States or trusted partners. If everything goes right, the United States could cover much of its rare earth magnet needs from domestic and allied sources by the end of the decade. New projects in places like Australia and Canada could also add to the pool. But that best case comes with a long list of ifs. New mines and plants take many years to permit, finance, and build. Environmental concerns, local opposition, and technical hurdles can all cause delays. Specialized equipment and skilled workers are still more common in China, and one category remains especially difficult: heavy rare earths like dysprosium and terbium, which are crucial for high-temperature magnets. Many forecasts say that even by 2030, the West could still rely overwhelmingly on Chinese supply for those heavy elements. So the United States can narrow the gap, but fully escaping China's orbit is much harder. Meanwhile, China is not standing still. It is not content with being just the world's raw materials supplier. By restricting exports of certain technologies and encouraging more advanced manufacturing inside its borders, China is shifting toward a model where it controls the most profitable and strategic steps of the chain. The aim is to be the place where the world sends ore and intermediate products, and where the most sophisticated magnets and components are produced. That creates jobs and value at home, and it also deepens everyone else's dependence. At the same time, Chinese regulators can tweak export rules as needed, loosening them to calm markets or tightening them to send a message. This is not a simple on or off switch. It is a dial that can be turned slowly, keeping foreign governments and companies guessing. For America's tech future, that raises a tough question. It is no longer just, will China ever cut off supply completely? It is also, how much control is the United States willing to leave in the hands of a strategic rival over the price, timing, and availability of critical materials? So what happens next? In the years ahead, we will see whether American projects like Mountain Pass refining and new magnet plants in places like Texas actually reach full scale on time. We will see whether joint ventures with allies, from Australia to Canada and Europe, can deliver reliable streams of rare earths and other critical minerals. We will also have to watch China's next moves, New export control lists, licensing rules, or technology bans could hit specific industries with little warning, especially electric vehicles, wind power, and defense electronics. And in the background, researchers and engineers are racing to reduce dependence on rare earths altogether. That means developing new motor designs, new battery chemistries, and smarter recycling that pulls rare earths back out of discarded devices instead of digging them all from the ground. If those efforts succeed, China's leverage weakens. If they stall, the pressure remains. So does China's rare earth grip threaten America's tech future? In one sense, yes. A large share of the materials that power United States phones, electric cars, wind turbines, and defense systems still depends on Chinese mines, refineries, or magnet plants. That gives Beijing a real lever in any major confrontation. But it is also a wake-up call. The rush to diversify supply chains, build new facilities, and explore substitutes shows just how risky the old model was. For years, the world chased the cheapest supplier and hoped that geopolitics would stay calm forever. Now the illusion has cracked. This is not just a story about obscure metals with long names. It is about who gets to build, power, and defend the technologies of the 2030s and 2040s, and whether the most advanced economies are comfortable having that future depend on decisions made in one capital city. In the end, the rare earth race is really a race for control over the invisible building blocks of modern power. And that race is already underway,